Hey, welcome back 7th grade. Today we're going to be looking specifically at problem 4.1, the beginning of our last investigation in this book for moving straight ahead. And we'll begin to look at using rise and run and becoming aware of the concept of slope of a line. Let's take a look. All right, so we're going to be looking specifically at understanding rise and run through the concept of stairs. So before we clarify that rise and run, I want to make sure you guys see this here. The idea of rise and run for stairs deals with that step going up, considering the rise, and that horizontal movement is going to be the run. We want to think about the rise in a situation as the change of the vertical. It could be up or down. It's going to also be the y value in an ordered pair or in a result from an equation. The run is going to be telling us information in the left and right horizontal or the x value. So we do want to make sure we are aware of one thing, and this is a key part, it's going to be part of our answers that they ask us about today, is that carpenters have developed the guidelines below to ensure that stairs they build are relatively easy for a person to climb. Steps are measured in inches. So the ratio of rise to run, that means ratio with rise on top of run in that ratio or fraction, it should be between 0.45 and 0.6. And the rise plus the run for each step should be between 17 and 17.5 inches. So we're going to be looking at that specifically today. So here's what we're doing for part A on 4.1. So determine the steepness of a set of stairs in your school or home. To calculate the steepness, you will need to measure the rise and run of at least 2 steps in the set of stairs, make a sketch of the stairs, and label the sketch with the measurements you found. Find the ratio of rise to run, and how do the stairs you measured compare to the carpenter's guidelines on the previous page. All right, we're gonna go outside and take a look at this. I have some stairs by my neighbor's house, and we'll put those in here right now. Let's go take a look. All right, guys, here we go. We're gonna be filming to see these stairs, and we're gonna test the rise and run of these stairs here across the street from my neighbor's house. So let's take a look. So first thing, come on in, the rise. We'll say that is 7 inches. Okay, 7 inches there. And the run is 17.5. Let's do this one again as well here too. Okay, that's 7 inches again. And 17.5 there as well. Okay. All right, so we're back in the house, taking a look at the measurements here. If you recall what we saw, the rise for both steps was 7 inches, and the run was 17.5 inches on each of those. So part of what we were asked to do is make a sketch of the stairs and label each sketch with the measurements you found. So this is what I found for mine, but I'd love for you guys to go and measure some stairs around your house or somewhere where you hang out, and that same kind of process to see if these work. So then it says find the ratio of rise to run. So what that means when we say ratio, we're going to be looking at rise over run. And in this case, because our rise is 7 and our run is 17.5, that's the ratio that they gave us. But we need to go in and calculate that out and see what it would be as a decimal. So let's go ahead and do that. So we're going to do 7 divided by 17.5. So I'm going to put a 5 here, and I'm going to add a 0. So we're doing that. And definitely need to put a decimal point here and come in that way. All right, so in this case, how many times does 175 go into this 700 in this case? And so what I'm going to do is do some multiplication to see what that would look like. And I think it's going to go in 4 times. Let's check that out. So 175 times 4. So 4 times 5 is going to be 20. 4 times 7 is 28. Plus 2 is going to be 30. And 4 times 1 is 4, plus 3 is 7. And look at that. Nice. We have a 4 here. 700 is going to be 0. So what that tells us is the ratio in this case is a 0.4 ratio. Now, remember the carpenter scales for question number 2. How did the stairs you measured compare to carpenter's guidelines on the previous page? Well, they said the guidelines needed to be between 0.45 and 0.60. So based on those guidelines here, for number 2, these stairs do not meet the carpenter's guidelines. And obviously, because that 0.4 is lower than that 0.45 to 0.6 range. Now, I know that didn't take too long to do that work there, but I'd love for you guys to try that out at your house, somewhere where you are. And if you would, take a picture of that, post it in with your assignment so you can actually see what's going on for those stairs as well. All right, so let's move on to part B. All right, so it says there, a set of stairs is being built for the front of the new Arch Middle School. The ratio of rise to run is 3 to 5. First of all, is this ratio within the carpenter's guidelines? So let's take a look. Oops, sorry, bumped the camera there. So B, they say we have a ratio of rise equals 3 to run equals 5. So that means we would have a 3 to 5. And if I do that division, it's going to be 3 divided by 5. Decimal point comes in, this one here. Yeah, look at that. We get a 0.6, which equals 0.6. And so the question is this ratio within the carpenter's guidelines? And over here, it can be in there. It should be between there. It's right at it. It's a little bit on the border. It's not quite between, but it's there. Okay? So number 2. It says there, make a sketch a set of stairs that meets the ratio, label the lengths and rise to run of the step. So I don't need to worry about it being exact, but you can just label those here, but I'll do that anyway. So we got the rise is 3, the run is 5, rise is 3, run is 5. I'm gonna label those. So I've got 3, 5, 3, and 5. And there are my lengths. So you can see that's what they asked us to do.